All right, today we're going to look at the concept of energy. And this is a very vague and hard to understand concept, so I'm going to start by thinking about an analogy, okay? So, what do you need to get stuff done in our world? If you want to get a house built, if you would like to have a new car, if you would like to go to college, you need something in common. What is it that gets stuff done in our world? Well, you're probably thinking money, and you are right. So money comes in many different forms, and we're going to look at some of those. We're going to use the word value instead of money, because money we tend to think of as just a single part of the system, but we're going to look at value. So if I said, what are you worth? If you needed some money to get something done, how much are you worth? How would you answer? Well, there's a couple ways to think about what you are worth. And the first and most obvious would be to say, well, what's in your wallet? How much money do you have in your backpack? So that's money that you have, and that's definitely part of what you're worth. But you probably don't have that much. Maybe you've got some envelopes of cash stuck away in your dresser from grandma that you could dig out and find, but probably not a whole lot of cash. But cash in your wallet is definitely one form of your worth. But there are other forms of your worth. Not only do you have cash, but you have what we call assets. Assets are things you own, and this is another part of the calculation of what you're worth. You might have an iPhone 11. You might have a car. Perhaps you have a bicycle or something else that is of value. And so if we were to calculate what it exactly is you're worth, we would have to add up your cash and somehow ascribe some value to each of your assets. But that's not it. There are other things that you have that are worth something. For example, you may have some skills. Perhaps you're really good at digging holes and somebody needs to dig holes. So you could get paid for digging holes. And so that would be a skill that you have that is part of what you are worth. Maybe later on in many, many years, you will be a surgeon, and that will be a skill that you have, and that will be worth a lot. So these are all things that factor into what you are worth. You also have something, because you're young, and there are many years ahead of you, you have something valuable, and that is time. So time has value, and you oftentimes get a job where you trade in your time, standing there scanning things at Needlers for customers. You trade in your time for some cash. So we take what we have in terms of time and maybe some skills, and we trade them in for some cash. And then perhaps you use your cash to buy an asset. But these are all things that are part of what you're worth. And maybe the most important thing is what something you have that isn't really necessarily worth that much right now, but it has significant potential. Your mom might say, you have a lot of potential. So what we mean by that is you have something which right now isn't worth much, but later on could be worth a lot if it's properly trained and you discipline and you work it and practice it. So we say that your worth involves not just what you have, but also what you can become. So your potential, what is saved for later. So those are all examples of worth. So when we talk about work, what does it mean to go to work? Well, most of us would say that work is the process by which you trade in your time and your skills and things you can do for cash. So we call that work, and we're going to use this later on when we talk about energy, because work we use the word in the exact same way. It's a transfer process. So when you go to work, you don't really manufacture money. Hopefully, what you're doing is you're trading in one thing that you have that is of value to your employer, like your skills and your time, and they are compensating you with another form of value, cash, or perhaps they're dealing with a direct deposit to a bank, so you never actually see the cash, but what you're worth goes up because the bank tallies that and keeps track of how much money you have in the bank. So when we trade in our time and our skills for cash, we call that process work. So work is not making money so much as it is transferring value from one form to another. Okay, so you take your time, you take your skills, and you turn that into cash. You take one thing that is of value and you turn it into another thing of value. So really, work is the process by which value changes forms. So if monetary value is what makes the world work, then we can think about that monetary value in two forms. We can think of what you're worth based on the stuff you have now, your assets, your skills, your time, and your cash. And we can also think about it in terms of stuff that will later be valuable. So your brain, your mind, your education, which is why everybody always tells you to stay in school, right? So that's going to get us to this idea of energy. So if we ask, what makes the physical world work? What makes everything go? The answer is energy. And this is the big idea for this unit. So energy you can think of as the stuff that makes everything work. For example, if you want to use your phone, it's got to have some energy, a source of energy. Something is needed to push electrons through the circuit to cause them to be able to run the electronics that make it connect to the cell tower, that make it possible for you to type on your screen, to display your messages and your cats and whatever else it is you're looking at. So all of that requires energy, so energy is what makes it work. If you want to make your car go, you need a source of energy. If you want to produce heat because it's cold, or maybe your house is hot and you want to cool it, you need a source of energy. If you want to toast your bread or dry your hair or pop some corn, you need energy. So energy is this kind of vague concept, but you can think of it as the stuff that makes everything work, that makes everything go. Now, we're going to make a big bubble map of the forms of energy. So at this point, I want you to get your notebook out, and you guys are going to work with me here to make this bubble map. And if I ever get ahead of you and go faster than you can take notes, you can always just pause the video and get caught up and then keep going, okay? But when this is all said and done, you're going to take a picture of your notes of this bubble map as evidence that you've paid attention and thought about these things, okay? So you're actually going to make this. So if you have some colored markers or some colored crayons and want to do this in color, that'd be great, but it's not required. But I do want you to take notes and make this bubble map with me, okay? So we're going to start with the central idea of energy. And right now, it's really hard for us to define energy. We're not really sure what it is. We've said that it makes the world work, but we're not really sure what it is. So we're going to put some concrete forms to this energy, okay? We're going to divide these up into two categories. We're going to talk about energy now, that is energy available right now, which we call kinetic energy. And we're going to talk about energy that is stored for later, which we call potential energy. Okay, so the first one is going to be energy of motion. So energy of motion is energy that something has because it is moving. If a bowling ball is rolling down the lane, it has energy, and that energy could conceivably be used to do something useful. A car that is moving has energy. So anytime something is in motion, it has energy because of its motion. And we could harness that in clever ways to turn that into something else. But energy of motion is called kinetic energy. The word kinetic comes from the Greek word kinesis, which means to move. So you've probably seen kinetic energy before in middle school science, but it means energy of motion. All right, now, a concrete form associated with energy of motion is wind. So if you've been up north towards Chicago or you've driven around the state, you've probably seen the big windmills that are located around. They are harnessing the energy in the wind. And what is wind? Well, it's moving air. So wind is a form of kinetic energy. It's energy that the air has because it is in motion. All right, so that's a form of energy now, the wind. Another form of energy is heat. If you take your hands and rub them together, friction will turn the motion of your hands into the motion of the molecules in your hands. And when molecules are in motion, we call that heat. So you may remember from Mrs. East, when you guys did chemistry, you talked about the fact that when something is hot, all the molecules are jiggling really fast. So if you've got some molecules, they're moving back and forth really fast if they're hot. So heat is a form of kinetic energy. It's a form of energy in motion, and it's actually what we call a molecular energy. It's the molecules are in motion. They're too small for us to see, but they're moving nonetheless. So that's another example of energy. Another example is light. So light is an example of energy, a form of energy, which comes to us mostly from the sun. That's energy now. We can harness that in clever ways and turn it into other kinds of energy too, which we'll talk about in a minute. Another form of energy now is electricity. So when you plug your phone in and you charge your phone, you are taking energy of electricity, and you're actually storing it for later in a thing called a battery, which we'll talk about in a minute. Now, in terms of energy that is stored for later, one of the most common ways we store energy for later is in chemical bonds. So you may know TNT. It stands for trinitrogen toluene, and it's a chemical which has lots and lots of energy stored in the bonds, and that energy can be saved and stored up and used for later. We use nitrogen bonds to store energy, to spray on the fields, to provide energy for the crops. So if you have experience farming, you know we put ammonia on the fields. Those are forms of energy. So you can store energy in chemical bonds. It's a little bit like squeezing a spring together and latching it together. It's got energy stored in there. If you were to let it go spring, it would zoom apart and the two pieces on either end would go flying. So chemical energy is sort of like storing energy in these little chemical bonds. Now, some common kinds of energy that we store in bonds are gasoline. So when you go to the gas station and you buy gas, what you're buying is energy. You're buying energy that is stored in a chemical form, and your engine will later turn it into motion. We humans don't run on gasoline, but we run on food, which is very, very similar to gasoline in many important ways. So food energy is the energy we take in that powers our body, that makes us go. And that comes usually in three forms, but carbohydrates are usually the ones that we're most associated with energy. You eat lots of pasta before a race, for example. And chemical energy comes in many other forms too. I put wood down here. If we had more room and were bored, we could also add things like coal and natural gas and propane. All these fossil fuels are examples of energy that is stored in chemical bonds. All right, if you think about the sun, it's producing light, but where does it get its energy from? Well, the energy from the sun comes from a nuclear reaction. So the nucleus of an atom is split, and that produces lots and lots of energy. We don't usually do this on a small scale. I don't think anybody has a nuclear toaster or a nuclear car, but we do have nuclear power plants. There's one down in Louisville on the river there. It's called Sandy Bottoms, and it produces electricity from the energy in the nucleus. The nucleus of uranium atoms is split, and that energy is converted to heat, which is converted to electricity. So there's lots and lots of energy stored in the nucleus. In fact, in a bucket of seawater, if you just had one bucket of seawater, that would be enough energy to power the whole country for a day. In one bucket of seawater, if we could harness the energy in the nucleus. But it's really tricky to harness. It produces incredible amounts of heat, and we are very careful because we don't want it to get out of control. Of course, a nuclear bomb uses this as the energy source in an uncontrolled manner to produce lots and lots of devastation. Now, there's another form of energy, and we call it gravitational potential energy. It's kind of a weird name, gravitational potential energy, but it's basically stored energy because of gravity. So think about a lake up high in a mountain. So in Indiana, we don't really have any of these. But if you think about a lake high in the mountain, you can use the water to make electricity. We call this hydroelectric energy. And the reason the water has energy is because of gravity. Gravity is going to pull it down as it falls and it goes over the dam wall. And it's going to turn that stored energy because of gravity into kinetic energy or electricity. So If you lived in a world where there was no gravity, then you would have no hydroelectric power. You could not store energy in anything by lifting it up high because gravity wouldn't pull it back down. So because of our gravity field, we have potential energy of things that are stored up high. All right, so that's an example of gravitational potential energy. And then I mentioned this before, but battery is a way to store electrical energy. So it goes on the stored side, so that's why it's over here on the right side of my diagram, but it's associated with electrical energy. And there's other forms of energy we could look at, but these are the main ones. So the idea is that we're going to study this thing called energy, and we're going to look at how energy is transformed from one thing to another. For example, how does light energy become food? How does nuclear energy become light? How does chemical potential energy become motion? So we'll look at those transformations. But right now, if you need to, go ahead and pause this video until you've got your bubble diagram complete, and then hit resume, and we'll keep going. We're going to talk about some forms of energy transfer, okay? Okay, so maybe you're back with us now. Maybe you never stopped. You're able to keep up. You've got a nice diagram, and at the end, you're going to take a picture of it for me. Right now, though, let's finish up. We're learning about energy transformations. So, how does light become food? So, think about a banana. Like, a banana has energy. You can eat a banana, and that will give you energy to do things. But where did the banana get its energy from? Well, the banana grew on a banana tree. But what made it grow? Where did the energy come from? Well, it turns out it came from light. And so there is a process that you guys all know about that takes light energy and turns it into food energy. And that process is called photosynthesis. So the important thing to remember here is that these processes change energy from one form to another. They don't make energy. Photosynthesis doesn't make food. It turns light energy into stored chemical energy. Another example, if you had lots of light, you lived in a sunny location, and you wanted to make electricity from it, you would use a solar cell. A solar cell does not make energy. A solar cell transfers energy from one form, light, into another form, electricity. Maybe you take your electricity and you then store it in a battery for later use. But the important thing here is that solar cells don't make energy, they transfer energy from one form to another. Another example, think about your muscles. Do your muscles make energy? I mean, if you run, your muscles made you go. But where did your muscles get the energy? They didn't make it, they transferred it from food into contractions, which made your body go. So think about your car. Does your engine make energy? No. If you had a car and you had an engine, and that's all you had, you'd be stuck. You couldn't go anywhere because you don't have any energy. Fuel, gasoline, is the energy which makes your car go. So your engine is a device which transfers energy from chemical potential into motion. All right? We're going to talk about that more in a later lesson, but today is just kind of an overview. So here's a quick summary. Energy is the property of matter that allows us to get stuff done. All right, we're just going to use that as our working definition for right now. This energy comes in two main forms. The first form is energy that is available now. We call that kinetic energies. And energy that is stored for later. We call that potential energy. So you should probably put this summary in your book as well as your bubble chart. These are the big ideas for the unit. So energy is a property of matter that allows us to get stuff done. Energy comes in two forms, kinetic, which is energy now, potential, which is energy for later. And the last thing is, energy can be transformed from one form to another. We call the transformation of energy from one form to another work. Just like when we're talking about what you're worth. When you go to work, you transform your skills and your time into cash. When we're talking about energy in physics, we use the word work to mean we are transforming energy from one form to another. So we call that work. So that's our summary. So what you need to do is take a picture of your bubble map and upload it to get your points for today. And later on in the unit, we're going to look at some of these different kinds of energy. We will look at kinetic energy and how to calculate it. And we'll look at some potential energies and how to calculate them. And we will talk about what is called the conservation of energy, the fact that energy can't be created or destroyed. We can just move it around from one form to another. And we will look at some of those forms that energy takes. Okay? All right, good job. Thanks for paying attention. And take a picture of your notes and upload that. You can take a picture by holding your notebook up to the camera on your computer and use the photo booth to snap a nice picture of that, which you can then upload. Okay, thanks.